Hi everyone, it's a great pleasure for me to be able to present our work here. This work is in progress with Ritam and my advisor Onkar. Let me first discuss the motivation that went into this work. We know that emergence of bulk can be well understood in the language of quantum error correction codes, so it's very natural to ask if there is any underlying principle or some general strategy to identify a semi-classical dual description of a strongly coupled quantum system. Now, in the theory of quantum information and quantum computation, a related question or related problem has been studied. Given a quantum circuit, does it admit a useful classical description? It turns out that a certain quantity called the Wigner negativity, defined in this way, serves as a measure of complexity to simulate quantum time evolution on classical computer. And a certain basis called the Krylov basis minimizes the growth of Wigner negativity with time. So this Krylov basis makes the time evolution look as classical as possible. Now here we can see a comparison of growth of Wigner negativity between Krylov basis and any generic basis. This blue curve corresponds to the Krylov basis and this yellow curve corresponds to any generic basis. On the other hand, it has been shown that the Krylov basis in DSSOIK model in triple scaling limit precisely corresponds to the length basis in JT gravity. So, taking inspiration from this story, we wish to study the growth of Wigner negativity with respect to length basis in JT gravity. So, what is the setup in JT gravity? We start with the Hartle-Hawking state expressed in the length basis, and then we wish to compute the Wigner negativity. So, to obtain Wigner negativity, we first compute this particular quantity defined here, and then analytically continue n to half. Now for this, to compute this quantity w to the power 2n, and see this w to the power 2n is actually given by Euclidean gravity path integral with this kind of boundary conditions. Now at leading order, this disk diagram is the one that dominates, and we compute this, evaluate this diagram, and we find in the end that Wigner negativity grows with time. So our calculation shows that Wigner negativity seems to be growing indefinitely with time. On the other hand, if one computes the growth of Wigner negativity with respect to Krylov basis in SSS matrix model, it looks like this, and it saturates at some point. So, is gravity aware of this feature? Now see, as shown earlier, this gravity path integral also admits various connected diagrams, and maybe one should explore these connected diagrams as well in order to be able to explain this feature over here. That's all that we had. Thank you for listening.